You might have heard that the temperature of the sun's surface is about 5,800 degrees Kelvin. But have you ever wondered how scientists know that? In fact, how do scientists find out the temperatures of the thousands of stars around us? The stars are millions or even billions of kilometers away from us. We can't visit them, we can't touch them, and we can't put a thermometer on them. So the question is, how can we measure the temperature of something that far away? Let's find out in this video. So how do we measure the temperature of stars? Using two clues. The first one is color. Think about a piece of metal being heated. At first it looks dark, then it glows red. Heat it more and it becomes orange, then yellow, and eventually white or even blue. The color changes because hotter objects emit different kinds of light. Stars behave in a very similar way. Cooler stars look reddish. Medium temperature stars look yellow. Very hot stars look blue. For example, the star Betelgeuse looks red, which tells astronomers it's relatively cool for a star. But the bright star Rigel looks blue, meaning it's extremely hot. And the sun is yellow, which means its temperature is medium. By carefully measuring a star's color, scientists can estimate its surface temperature. But color alone isn't enough, because two stars can sometimes appear almost the same color. So scientists rely on a second clue hidden inside starlight. They pass the star's light through an instrument that spreads the light into a rainbow-like pattern called a spectrum. But this rainbow isn't perfectly smooth. It contains thin, dark lines. These are called absorption lines. These lines appear because atoms in the star's atmosphere absorb very specific colors of light. Different elements leave different patterns of lines. In fact, each element has its own unique spectral fingerprint. And here's the important part. The strength of these lines changes with temperature. For example, hydrogen lines become strongest at around 10,000 Kelvin. In cooler stars, other elements like calcium or iron dominate. So by looking at which absorption lines appear and how strong they are, astronomers can estimate the star's temperature very precisely. So by analyzing nothing more than starlight, scientists can figure out the temperature of objects that are billions of kilometers away. No spacecraft, no thermometer,